How's it going, everybody, and welcome back to our Cisco Enterprise series. In this video, we're going to be touching on switch administration, which is the last of our switch campus topics, and we will be sailing straight into routing. So let us talk a little bit about managing the MAC address table. This is a topic of discussion that I've had multiple times with multiple customers, and it varies widely. Some people care, other people are like, yep, we know it's there. It's just, part of the switch process, which is true, it is. So there's really not a whole lot to managing the MAC address table. If I was to pull up Secure CRD and look at, for example, let me scroll down here just a little bit. Look at look at switch 6. And we're to show MAC address table dynamic. We're going to get two MACs. Let me go ahead and get out of the way. So if we were to look at the output, if we do a show, what is the output? I forget the output that I'm looking for, but essentially the point that show MAC address table, there is, so the configured, I'm trying to think of what the command is, it's not triggering. There is a MAC aging time. So MAC address table aging time is by default, actually let me just do a do show run all section MAC. The MAC aging timer, it's not, there isn't one set. Okay. So by default it's 5 minutes. So a MAC address will show up in the MAC address table for 5 minutes. So do show MAC address. So it doesn't tell you how many seconds the MAC address has been there though. So actually let me pull up my home switch. So switch 1. Show MAC address table dynamic. So it shows you the interface that it's learned in on, right? So we do show run all section MAC. So let's see here. Okay, so all right, I guess never mind. I guess it's not a switch-based thing. So I do know that the aging time is 5 minutes. So if you type in the MAC address table aging time, you would be able to come in here and set it to whatever value you want. So the lower the value, the lower the time that a MAC address will be saved in memory. That's really all that means. So if you were to say 10 seconds, and for routed MAC or for VLAN, and for both, if we were to do a show MAC address table aging time, MAC aging time, so it's set to 10. So let me go ahead and yank that out. So let's do this and do a show MAC address table aging time, 300 seconds, right? I wasn't sure where the command was, but there we have it. So it's 300 seconds or 5 minutes. So we know that is the case in this particular situation. So you can adjust that however you want to. So 5 minutes, the MAC address will stay on the switch and do its job. So that's what I wanted to show you when it comes to managing your MAC address table. That's one way of doing it. Another variation of that, which we already talked about, which is using the trunk allowed list. So you can go to a particular distribution level switch. So you're talking logically northbound of your access layer. So you'd make your change here to affect downstream switches, and you would configure those on the downstream interface on the trunk link. And you would simply say switch port trunk allowed VLAN, and then whatever VLANs you want to allow on the from the distribution layer down to the access layer. That's all you would need to do. That's how you would manage your MAC address table. There are other more advanced ways of doing that, but for the sake of brevity, that's what I want you guys to be aware of. There are some security features like 802.1x, and there's some sticky commands that you can do to control some of the MAC address learning, but for the most part, that is what you need to be aware of. So there's that. Now let's talk a little bit about layer 2 MTU. So I won't be able to do this because the layer 2 switches that I'm working with don't actually support this capability. But let me basically kind of break down this how this works. Layer 2, the MAC address works at layer 2. And so the default MTU, the maximum transmission unit, by default at layer 2 is going to be 1500 bytes. That does not include any of the Ethernet frame overhead and any of that type of stuff. So when we talk about this from the capabilities option, in the event that you want to increase the MAC address, so actually let me go back over here to this guy, and let me go to the show MTU, no, what is it, show run all section MTU. There should be an output for it. So we have the system MTU for routing is 1500 bytes, and you can see which is not the same thing as the IP MTU, so which is different. So the IP MTU is layer 3 MTU, which we'll talk about more when we get into layer 3 and how the MTU can be affected. But if we take a look at the system MTU is set for 1500. In the event that you wanted to do any type of communication above that, so if the system level MTU is 1500, and let's say you wanted to bump all your interfaces to be 9000, you'd have to come up here to global config and set the system, and then the MTU would be, in this case here, you'd want to jump that up. So I would say jumbo, and then you'd be able to come in here and jump up to 9198. So 9000 would be a nice round number. You don't want to max it out to 9216, which I think is the maximum value it'll support, or the maximum MTU possible is 9216. But most customers that I work with will go to an MTU of 9000, and that gets the job done. If I was to set this command to say 9000, I'd have to, and hit the enter key, I'd have to reload the switch in order for that to apply. So if I set the jumbo MTU, so I'm dealing with jumbo frames and I want to go bigger, so really all that does, instead of being broken down into 1500 bytes, I'd be able to do basically 6 times that. I'd be able to do 6 times the amount of data per MTU interval I'd be able to send. That's really what you're doing. But the key factor here is when you're talking about layer 2 traffic, and you would also want to do that for layer 3. So there is no command for layer 3 for this. You're setting the MTU, and you'd have to go set the IP MTU to be 9000 as well. At the interface level, and not for like routing and stuff like that. But in cases where you do want to use that would be in larger like data flows, like data center. You're going to definitely want 9000 MTU set there and stuff like that for MTU reasons with encapsulation and things like that. It just makes more sense to do that. And that essentially is layer 2 MTU. So what I don't want you to do is get like all tied up and if you want to understand the frame sizes and the headers and all that type of stuff, more power to you. But this is essentially what you need to know. I don't know if the command is even supported here. Switch 6, since we're right there. The system, yeah, it's not even supported here on the software switches because it's a hardware-based thing. You're changing how the switch is going to operate. Its forwarding operations are going to change. It's going to accept a bigger MTU. But for what I'm attempting to do within my environment, I don't need anything bigger than 1500. As a matter of fact, a lot of if you were to go with like a Cat 9K, I think those automatically start off at 9000 MTU, but it's negotiated, right? The MTU might be set at that value, but if I was to bring up my networking and settings here, and look at, let's see, let me see here. I'm on another screen. I'm trying to see if there's an MTU value. No, just gigabit. There's nothing really. Let me edit this real quick. Yeah, I can't even adjust the MTU on that. So, I mean, I probably could go and do some manipulation on my local NIC to get it to do something higher than that, but it's an Ethernet interface that I'm not really too concerned about. If it was a server, different story, but there's really no point in running anything bigger than that. As a matter of fact, if I was to do a show ARP and my IP, my MAC, show MAC address table dynamic, type include, this is my MAC address, gig 215, show interface status, gig 215, which is my Dell PC. If I was to look at the show interface gig 215, I'm negotiating full duplex. Oh, my MTU is 9,000. Okay, interesting. So the system MTU is different than the interface MTU. So, but we can see that that's doing 9,000, which is actually surprising. I did not realize that was what it was set to. But this is a hardware-based switch. So I'm actually a bit surprised on that, but that's okay though. So with that being said, that's just one of those other things where I would understand the different MTU types. But layer 2 MTU is going to allow you to send basically 6 times the data at one point in time, instead of having to send 1,500 bytes and send another flow, another packet, and so on and so forth. So just keep those kind of things in mind when you're looking at networking and how that comes into play. So with that being said, ladies and gentlemen, that is it for this video. If you have any questions, comments, concerns, feedback, please drop that in the comment section below. And if you haven't already done so, please like, share, and subscribe, and I'll catch all of you in the next video.